Hey guys, welcome to Software Engineering Daily. We're really psyched to have a chance to interview Vinayak Borkar. He is the CEO and co-founder of Mach5 Software. We're going to hear a little bit about Mach5. We're going to talk about new ways to think about search and improving search's performance and cost. We're going to talk about cloud native replacements for the search that you have today, especially Elasticsearch. Hope you enjoy the show and let us know how we're doing in the comments. Thanks. Hello, welcome to Software Engineering Daily. Vinayak Borkar is here with us today. Hello, Vinayak.
Hi, Jocelyn. Good to be on this podcast.
Well, I'm really glad to have you come talk with us a little bit. First of all, you were super excited to talk technology when we first met, and I definitely want to do that. But before we get there, maybe you could just give us a little introduction to yourself and what you're doing at Mach5.
Yeah, happy to. So I founded Mach5 in 2021. It's about 2 years old now. We're working on solving essentially problems in the data management space that happen to intersect with search. I've been in the data management space for about 20 years now, and I have seen the ways people struggle with dealing with data. The last 10 years, I spent building search solutions specifically for machine data management. And what I saw, my previous company was called X15 Software. We built a scalable solution from the ground up, specifically to deal with log data. We found that a lot of security customers used our solution to provide security features to their customers. And eventually X15 got acquired by FireEye. So I spent about 3 years at FireEye learning more about security. And the more I saw how people built solutions on the existing data management stacks, it kind of showed me where the gaps were, if you will, specifically around search solutions and being able to consolidate data that that arrives from multiple sources, so that one doesn't end up with silos of data, right? So that's really what my focus is with Mach5. We are basically building a search product that allows users to consolidate their silos, but at the same time save in terms of cost and modernize their solution by essentially moving to the cloud in a cloud native manner.
Okay, let's talk a little bit about that. So you're talking about an enterprise environment, right? You're talking about search over an enterprise environment that may have different silos. Let's talk a little bit about that. I want to unpack the problem statement because it's no joke.
Yeah.
The silos you're talking about are different lines of business. Sometimes they have. Well, let me ask you this: what do you think is the main problem? Why can't we just search across all the lines of business today?
Yeah. So again, there are multiple reasons why we ended up where we are in terms of multiple systems for managing data. What we've seen is, usually it is the same piece of data that requires different types of querying capabilities, right? So traditionally, there have been relational database systems which have been great at business analytics, where you can run SQL queries, but the what you need to do is structure your data in a form that the relational database can actually use it. And then there's a lot of work that goes into optimizing the data representation so that your SQL database can perform well, right? But it works great as long as your data is structured and you can express your queries in SQL. Traditionally, search has never been part of the SQL ecosystem, right? Search has always kind of been outside of it. And so over the last 10 or 15 years, there have been search solutions that have been built specifically for being able to deal with data, even without having to structure it. So, go back to how Google searches the web. When Google first launched, it just took all the they just took all the text, indexed it, and provided search without actually understanding what is behind that text, right? Nobody sat down structuring the web. So it's the same kind of strategy that's used for data, especially when the data is fundamentally unstructured or semi-structured. Where does this data come from? I mean, web pages are one, of course, but in the enterprise setting, logs have kind of the same um, characteristic, if you will. They are produced by applications. Every application's log is very different. There's no specification around these logs. So fundamentally, if you kind of look at logs in the aggregate, it appears like unstructured or semi-structured data.
Sure. I mean, it's interesting. Sorry, go ahead.
Yeah. So I was just going to say,
go ahead.
so the most effective way to get value out of your logs usually tends to be to index it in a search solution and get data, right? But it's to get results. Now, one of the challenges is, while search is a great way to kind of get your feet wet and get started with logs, very quickly the problems kind of escalate to, starting to ask questions like, okay, how frequently do I see this IP address? Or when was the first time I saw this IP address? So it starts looking more and more like what SQL databases are great at, right? However, search solutions are completely different beasts kind of that have been built from the ground up. And so now if I want to bring this different workload of being able to do more structured queries on the same data, I am forced to take the same data and load it into a different database just because search solutions don't have the same capabilities. Right? So this is really how we end up with silos.
So let's go back to the business problem here. Can you give some examples of, like, let me see if I understand what you're saying, because let's say I have like a boatload of just unstructured transcripts of customer call data, right? And it's just kind of keeps on streaming in all the time. And if I wanted to search that data, let's say I'd have to put it in Snowflake, or put some, time frame into Snowflake and then search it there. Is that's the problem statement? That's what you're trying to solve?
Well, so when we say search, right, search is kind of, let me be more concrete about what search means. Specifically, it's keyword-based searches, right? Like I'm looking for something that says, let's say your customer service data. I'm looking for a module that people are complaining about, let's say, right? And again, customer service data is interesting because there are different personas that can derive value out of customer logs, right? So for example, the person who is interacting with customers, the customer success person, probably is looking at it from the view of, oh, I need to find the specific, let's say, the specific workload is this person is interacting with a customer, and the customer says, hey, I'm having a problem with the module that does the UI. And so the customer service person probably wants to look at, are there other complaints in the same space? So what would they do? They would take some of the keywords that represent that module and perhaps search in the other issues that perhaps other customer service representatives have seen, right? So this is a classic unstructured problem, because you cannot really pose the question as something more concrete. It is literally, I'm taking keywords from what I'm hearing from one customer and looking in my database or my knowledge base to find other complaints, right? So this is one persona. This is the classic search problem. Like I'm looking for other things based on keywords. Then there is another persona. Imagine a product manager who's looking at a historic view of complaints that they've received or comments they've received from customers. And they want to take kind of a longer term view and ask the question, okay, what is the next set of features we should be working on so that we can perhaps reduce the number of customer complaints or make customers' lives easier, right? So this turns it into, it's not a search problem anymore. Like you're not trying to find a needle in a haystack, but what you're trying to do is looking for trends, right? So this is the dichotomy I was talking about. So there are the needle in the haystack type problems on the same data as a trend analysis on the same data, right? Unfortunately, the state of the universe today with data forces us to use different systems to analyze the same data in different ways.
So what system today so you've got one thing you're looking for, or you're looking for a pattern, right? describe for me without your offering,
Right, of course.
what system do people use for the one thing, and what system do people use for the pattern?
Right.
And talk about the problem of time,
Absolutely.
please.
So fundamentally, if I'm doing search, I would use a search-based product. So I mean, there are a whole bunch of products available today. The most popular one in the last 10, 12 years has been Elasticsearch, which is it's a popular open source product, and a lot of people have deployed this for specifically this use case, which is taking unstructured data or semi-structured data, if you will, and looking for needles in haystacks. Now, over time, Elasticsearch has added functionality for being able to do a little more aggregation and things like that. The challenge, however, is fundamentally the architecture comes in the way of being able to do extremely long-term analysis, right? As the amount of data grows in the system, one of two things happen. One is either the system grows so large that it is hard to manage the system, or it gets expensive to manage that, right? On the other hand, structuring that data and putting it into a relational database, relational databases have shown to scale much larger, like into it for over much larger sizes of data, and also you can express the queries in a way more precise manner to identify exactly the types of trends you're looking for, and the richness with which you can express what would you mean by a trend, for example. So SQL, has a really long legacy. It's been built. SQL has been built over a long period of time. People have understood these business analytics problems.
And Elasticsearch uses DSL, just people who aren't familiar,
Exactly.
right? It doesn't. You're right. It has its
Exactly.
own
Elasticsearch
thing.
doesn't do SQL. In some universes, that's considered a strength. If you don't know SQL, it's great because it lets you get
That's right.
in without having to learn a new language, which again is SQL is a pretty complex language, right? Um, so there are lots of domains I have interacted. I've interacted with people in multiple domains where they don't know SQL, right? So Elasticsearch is great for those kinds of personas. But at the same time, Elasticsearch doesn't do SQL. So if you want to do more precise queries, you literally need a different system, right? But this is what you would do. You
Right.
would basically take that data, put it into Elasticsearch, and put it into another system like Snowflake or BigQuery or any of
So for these two
these.
problem statements, like you're looking for one thing, looking for a pattern, we know Elasticsearch has architectural limitations, mostly having to do with like memory allocation. And it gets
Right.
expensive. It either gets too big, too slow, or too expensive, or
Right.
your choices, right, for very large data. And that's a problem for both the like right now problem as well as the pattern. The SQL, not having SQL, big problem in enterprise, right?
Right.
Because I know there is a little bit of snobbery around SQL. But the reality is, most people use SQL. Like most data analysts still use SQL. And I agree. I think it's very powerful if you know what you're doing with SQL. Then I would say, there's also like a data consistency
Right.
question in
Yeah.
Elasticsearch, and I feel like that affects the pattern matching.
Yeah. So the data consistency, I mean, this is kind of an age-old problem, right? The moment you make a copy of something and the human has to manage these two copies, they're usually going to go out of sync, right? So you have a data, fundamentally, by making the copy in two different systems, you have potentially run into a data consistency, right? And this is a different reason why silos, or rather this copying of data into multiple systems, is a bad idea, right? But however,
And everybody does it.
exactly, right? And at least, so my view is there are multiple reasons why people do it. And at least one of the reasons is because they want to bring different workloads to the same data, but there's no single system that's capable of being able to do that, right? That's one type of data consistency problem. The other is just because the data representation, like there's the structuring and the data that is indexed in these two systems, there is no single source of truth anymore. That causes yet another data consistency problem, right? It's literally that single source of truth that doesn't exist for a lot of these use cases. And so you might find your needle in the haystack, but now if you pivot over to this other system, you may or may not find any trace of it, because these two systems might have different. I mean, the reality is, each system is potentially managed by a different set of people within the same company, and so you end up with situations where the retention for one is different than the retention for the other, because each one is trying to optimize their budget, if you will, right? And each system costs different amount of money. So these are the reasons why you end up with data inconsistencies, which again can lead to, you're taking on more risk, which you perhaps cannot quantify to your business, because of inconsistencies.
Okay, so what we're saying is, in enterprise, you've got a lot of different pockets of search in all these different places, and that search can be for different reasons. Right now, finding one thing,
Right.
over time, looking at patterns. And Elasticsearch has a lot of limit. Your go-to might be Elasticsearch here, to sort of try and fit that over all of these different silos. But there's limitations.
Yeah.
And so this is what, go ahead.
Yeah,
You're working on, like, what's the alternative?
Yeah, I'm just saying, don't get me wrong. I mean, I'm not saying Elasticsearch is a bad product. It's actually an awesome product, right? I mean, it's kind of, the testament is, I mean, it's in the last 10 years, I mean, it has kind of gone through the roof in terms of how it's used. The problems with Elasticsearch stem from the fact that, it was built at a time when the cloud wasn't really a thing. And so, it's built on an architecture that made sense when you were deploying nodes on in a data center where you managed each node separately, right? So really, a lot of the problems stem from that, and they are fundamentally architectural. They are not, something that you cannot retrofit the declustering, or rather the cloud native implementation on top of a product that was fundamentally not designed for that, right? So the problems stem from that. But otherwise, I think Elasticsearch is an awesome product. We like the fact that that it provided an alternative at a time when the only choice was, oh, I have to use MySQL, right? That's where we came from. MySQL, Postgres, those were the two choices. And if you wanted to put any data anywhere else, like you wanted to do search, you were out of luck. Elasticsearch gave people an option. So it was it's a great product.
I'm glad you brought up architecture, because that's the next thing I wanted to talk a little bit about. So in the current world, right, you might have a really whole mixed architecture, right, of like all these different data sources. Maybe you've got some Snowflake, maybe you've got some on-prem, maybe two, right? You've got a whole bunch of different things. Those are both structured examples. Sorry, that wasn't a good example. You've got a bunch of S3, right? You've got a whole bunch of like unstructured or semi-structured data, different silos. And I believe, right, what you have to do is index it, have some kind of proper metadata, perhaps put it in a catalog, and then that from there you're able to search. That's high level, right? Where I think today land is. Where should it be in this new cloud world?
Well, I mean, this is so. Let's talk about like what do we mean by architectural issues, right? And maybe that will help.
Yes.
So essentially, what's happened is this, right? Over time, especially as your use cases get larger and larger, one of two things happen, right? So, for example, I'll give you, a lot of people are building multi-tenant solutions, right? So imagine you're a company building a multi-tenant product where the fundamental underpinning is search, right? So this happens for a lot of security companies. I mean, your example of customer service management, where you have a lot of CSR logs going into, or rather the transcripts going into a system, right? As you can imagine, not the how do I put it? Sorry.
That's okay.
So when you have lots of customers using your product, not everybody is going to use the product at the same time, right? So what happens? I mean, there are just these cycles where, it's daytime somewhere, it's not daytime somewhere else, right? And so on and so forth. And at the same time, so in other words, when you provision a backend which is static in terms of the set of nodes and so on, you got to provision for the peak, right?
For the concurrency.
Sorry?
Is that concurrency, right?
Exactly, because in the worst case, you might have lots of customers showing up, but then what are you doing all the time when that is not the case, right? You just have these machines kind of running, and just
And you're paying for it. You're still paying for it, right? Yeah. So this is Christmas is the Christmas time or holiday time is always the classic example for retail data, super spiky.
Precisely,
and then back
right?
to normal.
So you got to, so the traditionally systems have, were not built, these large scale systems were not built to track the spikes, right? So you ended up kind of provisioning for some kind of average, depending on what your budget allowed. But a lot of times, either when the traffic shows up, people are unhappy because they're not getting service fast enough, and on the other side, when there's no traffic, your systems are doing nothing, and you're just paying the penalty for that, right? So you kind of you don't. Yeah, it's bad on both sides. Now, the whole move towards the cloud has been essentially an exercise in trying to figure out how do we make systems more elastic in nature, right? How can they grow with demand and shrink when there is no demand, right? And there are two parts to any data architecture, right? So one is there is the storage component and there is the compute component. And like there's a saying that says data on a disk is as elastic as a brick wall, right? So essentially, trying to so as your demand comes in, trying to expand your I/O capacity to get to make more replicas so that you can service takes a long time. On the other hand, spawning compute or not spawning compute is very quick, right? So it's so traditionally when people build these nodes which have compute and storage together, I mean, think of it literally like you have a Lamborghini which can like really go fast, and then you have the store which is like a massive tank, right? You're essentially saying my unit of deployment is a Lamborghini towing a tank. Right? So you're going to be as slow as the tank in order to scale or shrink, right? So the whole move towards the cloud has been, can we have the tanks kind of handled separately and the Lamborghinis handled separately, right? So you can you handle these two separately. And so this is the classic. I mean, a bunch of the new generation of data warehouses have been going down this path, which is
this is Snowflake is kind of famously
Snowflake
the separating compute and storage.
Exactly, separating compute and storage. Databricks has the same kind of strategy of separating compute and storage, and so does Google BigQuery. So this has been the direction, and this has shown great promise in terms of being able to manage costs and track resources by demand rather than having some fixed allocation at all times.
So let's talk a little bit about what I have some questions. I want to come back to that because I know there's some subtlety right around managing, trying to get this scaling factor going faster. There's the cold start problem, query optimization, and I'm sure we're going to end up talking a little bit about that. But why don't we just kind of go back? I feel like we haven't talked about exactly what Mach5 is. So what is it, and how are you addressing some of these concerns technically?
Absolutely. Mach5 again, was built with because of three things coming together, right? One observation was when you look at the data warehouses of today and the data lakes of today, they are no longer just SQL systems of the past where you had to structure your data before you could query it. They have native support for JSON. In fact, some of them have been adding full text search as native capability. So data warehouses have been becoming two things. One is more cloud native and are capable of doing more than just SQL processing, right? Or rather, what you would call structured SQL processing. That's one. The second is the observation that in the last 10 years, products like Elasticsearch have gained a lot of momentum, and people have deployed solutions to use Elasticsearch as part of their offering, if you will.
Sure.
The third is that the costs of deploying Elasticsearch, as I mentioned earlier, and the cost of when I say cost, it's not just infrastructure cost or the licensing cost or the it's also the overall management cost involved in managing a system with this kind of architecture, right? It fundamentally requires a team to manage things like this. So
Right.
these three things coming together led us to kind of build Mach5. So what Mach5 does is it says, okay, can we build a better Elasticsearch or OpenSearch, where we meet the users where they are with Elasticsearch or OpenSearch, right? So they do not have to rewrite their application to realize this new future of compute and storage separation, or all the benefits that I'm talking about in terms of new architectures and just more adopting more cloud native thinking, right? And so what we have done is basically built Mach5 Search, which is 100% Elastic API compatible, if you will, or OpenSearch API compatible. So if you have an application built on top of Elasticsearch or OpenSearch, you can essentially just change the URL to point at Mach5, and it should not see the difference, right? So this does two things. One is, a lot of times I've seen companies, they it's kind of counterproductive for them to go re-architect the solutions just to realize cost benefits. So they end up kind of not doing that and spend a lot of both money and it's like a reduction in velocity, if you will, in their development, right? So it's one of those problems. So we want to kind of help customers not have to think about re-architecture, if you will, by meeting them where they are with their existing Elasticsearch stack. That's one. Uh, the second thing that we do is we're trying to also reduce the risk of making such a transition, right? So usually the type of offerings that face the problem with respect to cost and complexity are usually the large deployments, right? The last thing they want is the risk that comes along with having to adopt a new solution that claims to be better than their existing one, right? And so one of the things, like, we are very focused on trying to understand what risk means for such organizations and how do we counter that. So we've done a few different things. So as I said, 100% API compatibility is one thing, right? So we want to make sure that you replace Elasticsearch or OpenSearch with Mach5 and you'll get exactly the same results, right? The second thing we focus on is how can you incrementally move from your existing solution to Mach5, right? So there are multiple aspects to that. One is what happens to that boatload of data that I have indexed in Elasticsearch, or how do I migrate that to a new system, right? So we make that migration seamless. That's one. The second thing is there are certain pieces of functionality, and this is one other thing we are actually seeing with a customer right now. So in their specific deployment, so Elasticsearch or OpenSearch, I mean, this is a detail of the product, but there is something called cross-cluster search. So usually what happens is, as I said, there are silos of data. So one of the features that is natively built inside Elasticsearch and OpenSearch is this being able to uh, have one Elasticsearch or OpenSearch coordinator node or coordinator cluster be able to talk to multiple remote Elasticsearch clusters and kind of give you the view of being able to query that entire constellation through one place, right? So it gives you this ability to query multiple silos of Elasticsearch or OpenSearch.
And stitch together in one
Correct.
view or one output.
Correct. And a lot of large customers kind of have this kind of deployment just because each of those Elasticsearch clusters are handled by a different org and so on and so forth. Now, one of the side effects of this is, if you go to one of these organizations and tell them, hey, I have a better solution, maybe you should use us. The first question is, wait a minute. I mean, I cannot go around change my entire universe of deployments to say, rip and replace it with Mach5, right? So one of the things that we've done is built cross clusters. Like, we basically look like Elasticsearch or OpenSearch to such an extent that we can participate in this cross cluster search universe, right? So let's say I have 10 deployments of Elasticsearch, but really only one of them is this has a large amount of data. The others are fairly small, or the users are fairly happy with what they have. Then Mach5 Search can be you can incrementally replace that one deployment which is problematic.
Okay.
Mach5.
Let me back up a little bit here then. So the idea is that Mach5 is an enabler, or it's a replacement for Elasticsearch.
It's a replacement for Elasticsearch, right? but
it works in partnership with this with OpenSearch,
with
right?
other instances of Elasticsearch and OpenSearch. That's right.
Okay, so it can kind of weave itself in
Exactly.
to your existing Elasticsearch.
Yes.
Or if you want to like really rip and replace, you've got OpenSearch, which I'm not as familiar with it as I should be, but it's comparable to Elasticsearch.
Yeah. So
Is that right?
yeah, there is some history there. So what happened is Elasticsearch up until version 7.10 was fully open source under the Apache license, and at 7.11 onwards, they switched the license to be proprietary.
Okay,
Okay.
I get you.
And so AWS forked the 7.10 version of Elasticsearch and rebranded it as OpenSearch. And now
Gotcha.
they have, OpenSearch is a fully open source, Apache compatible
Okay,
license.
so I've got Elasticsearch or I've got OpenSearch, and I'm like, okay, I'm going to use Mach5. I would say there's two questions that you've answered one, which is like, is how do you make it less painful to switch?
Yeah.
But the first question really is, it's got to be so much better, right? The two things that always
Yes.
happen in these situations is you've got to show like, hey, I'm so much better than
Yes.
other offering.
Right.
And then they're like, well, I agree it's great, but
Yes.
it's going to cause me a lot of pain to get over to you.
Right.
So you're kind of answering that second part of the question.
Right.
Help me understand why customers are like, yes, your
Yeah.
thing is what I want.
Yeah. Bunch of reasons. So the thing we kind of talk most about is, from a cost standpoint, Mark 5 costs you either like 90% lower in terms of costs, right? So in other words, it will cost you a tenth of the price that you would pay for deploying either an OpenSearch or an Elasticsearch
Yeah.
cluster.
I'm going to come back to it. Give me the list of awesome stuff, and then we'll come back to it.
Sure.
We'll go through it.
That's one. The other is a moment ago I mentioned that one of the problems with the existing products is tracking trends, tracking spikes and valleys, if you will, in consumption, right? One of the things that Mark 5 does is it does this automatically. So users don't have to sit there and provision saying, oh, now expand my cluster or now contract my cluster, right? So this is something that's it's completely auto-managed, right? It uses Kubernetes under the covers to automatically track requests, track latency, track storage capacity, and scale every part of the system independently so that it can track consumption. So users don't have to do this. So from a fault tolerance standpoint, from an availability standpoint, Mark 5 is completely self-managed.
Okay.
Right? That's the second value prop that we bring to the table. The third is Mark 5 is available on multiple data warehouses and data lakes, right? So, for example, a Mark 5 can be used today on top of BigQuery, on top of Snowflake, on top of Databricks, right? And on top of object stores. And so the essentially as a consumer of this, it's not only that you have a single system to go to, you also get to decide which backend you want to pick in terms of being able to deploy and use Mark 5 or do search against.
Okay.
Right. So this is another way we reduce the need for silos, because if you are already a BigQuery customer, then you would essentially bring Mark 5 on top of your existing data, and now you can do search also in addition to the structured work that you're doing. You don't have to take the data out of the system and go index it in a separate system just so you can do search. And same thing applies for Snowflake, and same for Databricks.
I want to come back to that. So those are the big three. Anything else?
No.
Okay, those are big. Don't get me wrong.
Yeah.
Those are big. So let's kind of start with. I'm going to start with the last thing you said and kind of work my way back. So the example you're giving here is let's say I have a lot of auto loans.
Right.
And I've got one group that's just pulling all this auto loan data into BigQuery, just gobbling it all up.
Right.
And that's a place where I could look things up if I want one thing. Then I've got a bunch of data scientists who are pulling data who are also collecting auto finance data. I guess my question is, how they might have different schemas. They might have different kind of data definitions.
Right.
Would I have to resolve that in Elasticsearch and then replace it with Mach5, or does Mach5 help me figure out, it sounds great to be able to
Right.
search across data stores, but
Right.
in reality, it can be tricky.
Right. So, okay, a few different things here, right? So your alternative would have been to suck that data out of this data warehouse and index it in a different system, let's say Elasticsearch or OpenSearch. And at that point, kind of, you're essentially setting up an ETL pipeline that that does this.
And that's where I'd rationalize all the data types and normalize it, right?
Now, the nice part about these modern data warehouses is they have full text indexing as a native capability in these platforms, right? So BigQuery added ability to do search. The Snowflake just released what they call search optimization, which allows you to do lookups against the data, not just for equality lookups, but also substrings and so on and so forth, right? And the idea here is every Elasticsearch query. This is where Mach5 comes into the picture. What we have done is we built the technology needed to take Elasticsearch DSL and turn it into SQL against your existing table.
Wow. Okay. Right? That's a big difference.
Exactly. Right. So this is really so, and Elasticsearch DSL is very different from SQL, and in fact, in terms of capabilities, and I would say sometimes it is more capable than what a single SQL statement can do. So this is the technology we've built, which is being able to take the DSL and turn it into efficient SQL that is, again, and we custom built the SQL for every data warehouse separately, right? So we know what Snowflake.
You have your own SQL.
Exactly. We know what Snowflake is great at. So we build the SQL that works well with Snowflake. We know what data BigQuery is good at. When we generate SQL for BigQuery, we generate it so that it's optimized for BigQuery, right? So so from a consumption standpoint, you just use the Elasticsearch DSL as if it's Elasticsearch, but we query the data that resides in your warehouse by bridging the gap.
So if I'm just using the Elasticsearch query language, and then you're translating it for me, and you're calling the underlying data capability in whatever data store.
That's right.
How does that remain performant?
Yeah.
Like how have you handled that?
So a bunch of things. So where do performance issues come from, right? One is as you add more data, you need a system that scales, right?
It's got to grind through more stuff, right? Yeah.
Yeah. And the good part is, that's what these data warehouses have been built for. They know how to scale on insane amounts of data, right?
That's right. I'm not to interrupt you, but I just want to, the question, and maybe I'm not posing it in quite the right way, is just that, there's a lot of bad SQL out there.
Yes.
And it jams up the whole system. So how do you deal with that?
That's right. So, one of the things that cloud has enabled is, in the past, I had a fixed amount of fixed amount of infrastructure to run all my queries, right? Because it was on-prem and I had committed to a set number of nodes. So one bad SQL will consume my resources to an extent where the other SQLs are essentially choked out. Right? But with the cloud, this is different. What happens is you essentially, when your queries come in, they tend to kind of scale with the queries that are coming in. So a bad SQL doesn't really come in the way of, other.
I like what you're saying. I think what I would say is no worse than today then, because it's still costly. There's still a cost attached. Okay, but you're right. It won't slow you down, but it can still cost you. But if you had bad SQL before your thing, you still have bad SQL now that's driving costs.
Precisely.
Okay.
In fact, I would go one step further. I would say if humans were to, just from the experience having built Mach5 and done these, the performance analysis against these systems, I can tell you the chance that an average person trying to manually convert an Elasticsearch DSL into SQL will probably yield worse SQL.
Yeah, I buy that.
Right?
Yeah, I buy that.
The other thing we do is it's not always that, right? So we also have mechanisms for augmenting your existing table with additional fields, right? Which store data in slightly different ways, which accelerate specific search queries, right?
Okay.
Which these data warehouses perhaps cannot handle. So what Mach5 does is it kind of gives you this view of Elasticsearch DSL, not just from a capability standpoint, but also a performance standpoint. So, with one of the things people expect from a search solution is snappy results, right? So that's another thing that we keep focusing on, which is how do we make the results extremely fast with Mach5 against your data warehouse, right?
Okay. So working backwards from your big three.
Yeah.
The third big one, that was, hey, you can fit this over you can fit it directly over all these data stores and run search. Going back to the second thing you mentioned is this idea of tracking an architecture that allows you to track trends. Let's talk a little bit more about that, because you kind of had two ideas in there, right? Which is a little bit around looking for patterns in the history,
right,
which is a time problem. And then you said some other stuff that I didn't quite get around latency.
Okay. So let's talk about the patterns, right? So as I said, so if you think about all these cloud native data warehouses, they've been built for analytics from the ground up. So for them, time is an important factor, and they already kind of implement partitioning by time, for example, right? So traditionally, what happens is, what I've seen with a lot of security products is, because the product needs to offer full text search, they would keep like the front of the data, like let's say the last 30 days of data in a search solution, right? Elasticsearch or OpenSearch. But historical data is also important, so they end up kind of loading that same data into a data warehouse where they can do historical analysis, right? Now, one of the ways we achieve, our whole point is you don't need these two systems, right? We essentially bring those two down to just having one system, which is your data warehouse, right? And now your Elasticsearch API or the OpenSearch API can basically query the same database. The reason we are able to kind of get you the same performance as before is because we natively use the native capability of partitioning that these data warehouses offer.
Yeah.
So if you essentially say, I want to search over only the last 30 days, there's no reason to touch the 13 months or the 5 years of data that I have.
So let me just see if I understand this correctly. So, today, what'll end up happening is we'll keep the freshest data kind of local.
Yes.
And then historical data gets shipped out, right,
yes.
on some regular basis for historical and analytics. This is typically done for performance and cost reasons.
Performance and cost reasons, exactly.
But in the cloud world, if I have a cloud native data store, I don't have this problem anymore.
That's right.
Right? Because I just have an undifferentiated pile of data across these partitions that's as costly or is saving me money in whatever way. And so as a result of that, when I have it all in one place, Mach5 can search it all in one place. How is that different from why can't Elasticsearch do that, or can it?
Well, Elasticsearch is a full stack solution built from the ground up. So it has its own storage. So Elasticsearch can query data as long as you put it into its storage.
Oh, yeah. I'm sorry. Yeah.
Right.
So, but I guess my question is, that was a little bit of a misstep. I guess I'm trying to say, are you telling me about a capability that's cloud native or a capability that's special to Mach5? That's what I'm trying to understand.
I think it's leveraging the capabilities that are offered by the data warehouse, right? So we're using
making the most of the architecture.
Exactly, using the strengths of what the data warehouse gives us. The trade-off you have today is data warehouses are great to kind of have this like a large amount of data, like historical data, all sitting there in a much cheaper medium. The challenge, however, is they don't have the same APIs, right? So as an application, I now have to either have this two-headed monster,
heavier lift for
I'd have to re-architect my product to use the data warehouse.
Right. Okay, that makes sense. Thank you. Let's go to the heavy hitter, which is the first thing you started with, which is a 98% less cost. I really want to unpack why that is.
Yeah. Few different reasons again. So tell me how technically you want to get, but here is
as much as you want. I'll raise my hand when I get underwater.
Awesome, no problem. So here is how it happens, right? So let's start with just deploying these nodes. As I mentioned earlier, you have, so when you bring data in, you got to provision for a bunch of different operations that happen in a search product, right? So first is being able to ingest the data at the rate at which it arrives. Okay. Now, even that usually is not steady. It's bursty. Right? Data arrives at some point, right? So you have provisioned your system to be able to handle the burst of data, so you don't lose it. That's one, right? That's ingestion. The second is being able to index that data. So whatever data arrives has to be indexed, right? Now, usually what happens is, because your the nodes can fail in any setting, right? In your data center,
any time.
and usually when we say nodes fail, 95% of the time or 99% of the time, it's the drive that has integrity errors. It's the disk that fails. It's not the compute that fails, right? Um, so what one ends up doing is replicating. So if you look at how Elasticsearch or OpenSearch is deployed, is you end up with like 2 or 3 replicas of the data. So now the same data that comes in is indexed and stored in 3 copies in your cluster, just so that if you lose a single node, you still have access to the data that came in, right? So you just multiplied your compute and storage by 3x, right? That's one for ingestion. The second part of it is all the technology that is used by Elasticsearch or OpenSearch is based on uh, a certain way of managing data. It's called log structured merge, or LSM. It is essentially the way, in short, the way it works is, as new data arrives, the system builds tiny indexes with whatever data arrived in the buffer, and then over time you end up with lots of tiny indexes. Now, when a search query comes in, you essentially search every of those indexes and merge the results from that. The problem with this approach is, very soon the number of these tiny indexes grow and it starts becoming slower. So there is a separate process that is usually run called reorg, or reorganization, or merge, right? What that does is, it takes a bunch of tiny indexes that were written and merges it into a larger index, right? So this is a background process that's constantly happening. And you essentially take 10 of these tiny indexes, create an index that is 10 times larger, right? And again, the index that is 10 times larger may also not be large enough, especially as your amount of data grows. So you take 10 of those larger indexes, merge them to create what effectively now is a 100x larger index, right? So you're constantly reading and writing this data to reorg and merge the indexes, right? So now you have to provision your compute and storage capacity for being able to do this background process. And it's usually proportional to the amount of data that is coming in through ingestion, right? So this is the second process.
You've got ingest, and you've got this index merging business.
Merge and reorg, right? And finally, the thing why it exists, being able to query, right? That's what
the thing you wanted to do in the first place.
Exactly, right? So all this is just making of the sausage. Now you're actually getting to the meat of, okay, now I built all this because I want to be able to query it. So now you have to provision for your queries. And again, as I mentioned, queries can be large or small, and lots of people might show up simultaneously or not. So essentially very bursty traffic, right? So now put these 3 bursty things together, and now you have a cluster that's set up.
Circuit.
Now, the thing is, the observation here is, these 3 things have completely different phases in terms of when they need to be scaled, right? And what it means to scale each of these. So what we have done at Mach5 is essentially built this entire process from the ground up. The indexing strategy, the way the index is represented, the way merges and reorgs happen, in such a way that each of these parts can be scaled independently of each other. So for example, if I'm getting a lot of data, but I'm not getting any queries, just take that example, then I can essentially just scale the ingestion part for the duration at which I have bursty traffic for ingestion. Similarly, when I need to reorganize my data, I can launch that. And again, that's one of those things where the system decides when it's a good time to do it, right? So again, gives us a lot of flexibility in terms of being able to scale that when needed, right? Also, because we are in the cloud, we can launch these nodes just in time, and they're not nodes that are just sitting around, right? And on top of that, kind of being able to use like spot instances that cloud providers provide, give you, you get essentially a 10x improvement
Hmm.
on even that, right? So there are a whole bunch of, like, if you deconstruct what happens inside these systems and kind of take the first principles approach to building the system from the ground up, there's a whole bunch of opportunity to get massive cost reductions.
All right, I love what you're saying. At first, I was like, okay, a lot of people are like, hey, I'm going to use the cloud.
Right.
Great. But one of for myself as well, coming out of like years of software, it's interesting. Truly thinking in a cloud native fashion
Right.
really turns so many of our assumptions
Yes.
on their side.
Exactly.
And that's really, it's a place of real opportunity. I find myself getting kind of hosed up in that thought process every once in a while. But this is really, I think, what you've done. And I love that you said about the first principles, right? You've taken this new paradigm and you've really forced yourself to think, okay, how is time working?
Right.
In this environment, different from linear time, which we mostly spend.
Yeah.
We've spent all of our time thinking about.
Yeah, lift and shift is not the answer, right? And that's pretty much what people do when they deploy OpenSearch and Elasticsearch essentially today on the cluster. Or in the
Okay, interesting. So by kind of orchestrating and turning the knobs on these different activities, you're able to get a much
Yep.
more efficient
Yep. And
and
also
less
redesign
expensive.
of the index. I mean, the index has been designed from the ground up to be able to be very selective about what participates in a query. So you don't end up with, oh, I need to keep the entire index in memory.
I know you said like how technical you want to be. We're going over a little bit, but do you have time to talk a little bit
Yes, I
more?
do.
Because I wanted to ask you, this is like one of those vulnerable questions. I have to say, I've worked in tech and data for a long time, and how should I think about what you just said? You have a different approach to indexing. I've heard so many people say that. Like, how should you think about indexing? What's a good index, or how are you thinking about it that's different from others?
Well, I mean, so again, if you think about Elasticsearch and OpenSearch, I mean, both of them are based on uh, um, the library called Lucene, which again, if I'm not wrong, I think it has its origins in 2002, 2003 timeframe. And over time, of course, it has evolved. And Lucene is an awesome library. Like, I learned a lot about full text indexing from Lucene, right? So it was the first open source library out there that was industrial strength, and kind of, I think it is. I don't know anything else that is better than that.
It was a revolution. It was a revolution. I am dating myself, but you had to build everything yourself before that,
Yeah,
right?
exactly, right. And it was all bespoke and so on. So over time, Lucene has done lots of good stuff in terms of indexing, right? But still, the problem is that it has always been this thinking of my compute and storage is attached, right? Also, you kind of think of it in this: I'm sitting in a box of where my compute is, my memory, and my storage is, and my index
Yes.
lives there, right? If you think outside that box, I mean, I don't, it's cliche, but
I
if you think outside of that box,
I get it. That wasn't planned. I get it.
you can do amazing things. You can,
Yeah, I'm surprised. Yeah.
right?
Go ahead. You can do amazing things.
You can do
Like
amazing
what?
things. And again, even within the index is not like a monolithic thing. There are lots of little parts in an index, right? There's an inverted index, there's scoring, there is a whole bunch of things that go into kind of the data structures that make up an index. And so again, if you are willing to deconstruct that and try to figure out what how queries impact various parts of the index, you kind of have a very different view on what needs to be where, right? What can be in long-term storage, what can be in short-term storage, what can be in memory at any given point in time. So again, you get a lot of, so as you move to long-term storage, like keeping something in S3 costs you like 2 cents per GB per month, right? Putting something in memory, extremely expensive, right? But at the same time, the latencies are reversed. So you could take a very, blunt answer to this thing, which is take everything and put it into memory. That's going to cost you a fortune, right? So what we have done is tried to figure out basically how do we treat this memory hierarchy, if you will, of memory, local disk, and the data warehouse, or object stores, if you will, right, which have longer latency sometimes. How do we use that use the strengths of each layer, but at the same time uh, don't slow down because of the latencies. So we kind of
Yeah,
this is really how you think about redesigning that index.
that's amazing. I should have started there. I think that's amazing and very interesting. I'm glad you were able to explain that to us. We'll have to do another show on deconstructing indexes
Sure,
because I'm,
happy to
I'm
do
kind of
that.
interested in that. But I wanted to just I have a couple more questions about the product. So in terms of like, where are you in your product maturity right now? Are you
Yeah,
working with design partners or first customers, or kind of like where?
yeah,
Let's go to the business. Let's talk about the business and implementation.
absolutely. So our first product we built was on top of Google BigQuery, and we've been in
Mm-hmm.
GA since October, and we have a bunch of users who are using it today in production.
Okay, great.
And
I should have looked that up. Sorry. Thank you. I should have looked that up earlier.
I
Thank you.
mean,
That's
and
good.
I mean, we have a community edition that we made available when we went GA on BigQuery, which
Mm-hmm.
you can go to our website and essentially just uh, get the VM and run it in your GCP environment on top of your
Okay.
own.
And we'll put that in the notes. We'll put all that in the
Right.
notes for the show.
You can do that today. Since then, we've also kind of, looking at the popularity on BigQuery, we're basically looking at other data warehouses and data lakes, because it looks like the message does resonate, and a lot of people seem
Mm-hmm.
to have this problem, but not everybody is on BigQuery. So we are essentially, we built a product on Snowflake and on Databricks in the last, I would say, like few months, and now we are in beta working with design partners uh, to launch this product and get into GA. Right, we are in POC on both these platforms, and finally, so our goal is to essentially, once we have a couple of marquee customers on each of those platforms, we will be going GA. But in the meantime, if you any of your listeners feel like they can help us shape Mach5, we are absolutely yours to take on design partners on any of these platforms.
Great, great. And then just moving over, we interview a lot of technical founders on the show. You've had an interesting journey. This is not your first startup, right?
Right.
What advice would you give to other technical founders of what to do or not do based on your experience?
Oh man. Okay. Uh, let's see. Yes, you're right.
I'll give you some, yeah, I'll give you some prompts. Like some people feel like, oh, my best thing is sitting quietly and being technical, but now I just talk all day. Other people are like, oh, I have to have a killer idea. There's things that are kind of blockers for a lot of technical founders. You know, sometimes some
Yeah.
of our guests have some interesting things to say about that.
Yeah. I mean, again, I don't know if I have advice for anybody, right? Because everybody's journey is unique. But my general, like, for me, my strength was always like being able to multitask came naturally to me, right? So doing one thing, I'm actually more productive when I do multiple things.
Okay.
So that's one. The second is also, it was kind of a limitation of in terms of what I made me happy, right? So just working on a technical problem in isolation never made me happy. I always needed to see kind of the business impact, or I don't want to say business impact. I wanted to always see how it made a difference to users, right? So I always sat at the cusp of doing engineering as well as, I would say, product management, if you will, right? Outbound product management.
Mm-hmm.
And so there are very few roles that let you do that. So I think as one of like building a startup is actually one of the ways to do that. And so that's why I think I like this model, right? But at the same time, like a lot of people kind of glamorize like startup, like being a startup founder. I mean, one thing I want to remind people is, when you work at a company, you have a lot of support. You have people to do things. When you need something done, there is a person to do it, right? If it's not directly within your purview. As a startup founder, it's exactly the opposite. Essentially, you cannot hand it off to somebody. You got to figure out pretty much like every aspect of what needs to be done.
Mm-hmm.
And to some extent, I enjoy that, right? Because it kind of gives me an overall like view of what's happening, and it kind of lets me balance the things that one should do and should not. But the biggest, I would say, thing is that for me personally, that has helped me is I have had the privilege of being able to work with amazing teams, right? And again, like over my career, like I've met people, and along the way, somehow, they have been excited to work with me in the future. And so, I've been able to put together these teams. And without the teams, I can tell you, I can never have successfully executed in any of the startups,
Mm-hmm.
right?
Mm-hmm.
Um, so I think I don't really have
I like that.
a
No, I like that. People first, and you get on the. I want to talk more. We'll do another show about how you end up being in great teams because that's a special skill.
right,
But I also really like what you're saying. I think that's right. If you find yourself with one foot in product management and one foot in like serious, tech,
right,
you might be a prospective founder of a company because there's not a lot of roles like that.
that's
That's
right.
really interesting. I think I'm going to think about that more. Well, what's next? I should have asked you about I forgot to ask you about generative AI, and because everyone's talking about that, we'll have to come back and talk about your opinions on that. It was on my list of things, but I'll let you go. What's next for the company? What?
Well, I think we are on this journey to kind of build this product, which I hopefully we can get into more customers' hands, and get this to a point where we actually realize our dream, which is make things more efficient, just from a resource consumption standpoint, and kind of like where people need to focus their energies as they deploy these solutions, right?
It's amazing. In very large organizations, and my background is really in the financials. This is a very sought after.
Yeah,
Yeah, I'm not saying you've completely solved this problem, but the endpoint, right? The ability to search across,
right,
all these, they're all collecting so much data,
right.
but it's such a heavy lift
Yes,
to get a unified view that you can search.
that's right.
And if you could do it, especially in finance, right? The ability to compare
Right.
tons of different data from different sources makes your analytics so much stronger.
Absolutely.
The outcome is so much better.
Absolutely. I mean, you hinted at what's the next for AI, right? So I think, I look at what we are building as an enabling technology for AI. Like without data, AI is nothing, right? And that is one of the things. And also with wrong data, AI is worse than not having AI, right? So I think what we are making possible is bringing all your data in one place. So if you want to train models, you have more power on your hands, just by virtue of making sure you have the right data in your hands, and also in a timely manner, right?
Yeah. And without the implementation left.
Yeah.
It's really great to talk with you. I definitely want you to come back on the show and tell us more as you evolve your
Absolutely.
technology, and we can deconstruct indexes together, which is perfect for this show. And I hope you have a great rest of your day. Thanks for coming
Great.
on Software Engineering Daily.
Thank you, Jocelyn. This was great. Thank you so much for having me.